Hi, this is Austin with Radical STEM Tutoring, and today we're going to solve the integral of tangent of theta. So in a lot of calculus classes, this integral might be given to you in a table, or it might be something that you're just expected to memorize and know the result, but that won't always be the case. So we need some way to get the result if we don't remember it off the top of our heads, so we're going to do it manually today. Now, we can start by remembering that tangent is defined as sine over cosine. And now we can do a trick with some u substitution. If you remember that sine and cosine are derivatives of each other, if we choose one of these as our u, then when we take the derivative inside of our u substitution, we'll end up with the other one. So why don't we strategically choose cosine? So we will let u equal cosine of theta. Now when we take the derivative with respect to theta, well, the derivative of cosine is negative sine of theta. Okay, now let's bring that d theta to the other side. And we have sine theta, d theta in our integral that we could replace. So let's just bring that negative over here to the du. Then we can replace sine theta with minus du, and we can replace cosine with our letter u. So now our integral equals negative 1 over u du. And if you remember, this is actually equal to the natural log. That's negative natural log of u, and be sure that's in absolute values. Then we'll add our constant of integration. So one more step to go back to our original variable. Remember, u was just cosine of theta. So that's a perfectly valid answer. You could stop right there and be done, but a lot of times you'll see this integral given in a different form. If you just stop right here and you look it up in a table, you might not think that you have the right answer. But we can actually do a little trick with the natural log to get this in the form that you'll see in a lot of tables. So if you remember, with natural logs, if you have a number in front, like a -1, then you can bring that inside the natural log and raise whatever you have inside to that power. So we're going to do the same thing right here. We're going to bring this -1 inside to have cosine of theta to the -1st power. Remember, -1st power just means it's 1 divided by cosine of theta. And 1 over cosine of theta is actually defined to be secant of theta. So that is what you'll see in a lot of textbooks or tables, that the integral of tangent is natural log of the absolute value of secant. But these two actually mean the exact same thing, and they're both correct. Alright, so if you found this video helpful, please be sure to like and share, and have a great day.